Welcome back, AGS fans. Today what we're going to be doing is graphing sine and cosine functions. So example A is going to be a sine function. Example B, we'll highlight in yellow here, is going to be a cosine function. And the goal for today's lesson is to be looking for 5 key values. So I'm going to highlight that in blue down here. And we can see these two graphs below. One of them represents sine of x. It's like a generic sine with an A value and a B value. We'll talk about what those mean in a little bit. And the other one represents cosine. All right, so what we're going to be starting with is when we're graphing one of these points, I've got this function y equals sine of x. So for this one, there is no A value written down. This is going to be like A equals 1. And we're going to talk about what that A represents. It actually stands for amplitude. Whenever we see the letter A, that stands for amplitude. All right, so here on the top right, I have a circle drawn. And one thing that we've talked about before with the circle was whenever we're looking for a point, like let's say x comma y on the circle, if we want to find the y location, that's going to be a sine function right there. So it would be sine of, we'll just call it angle theta. Sine of theta equals y over r. R is whatever the radius is. In this case, the radius is just going to be 1. If I look around this circle, I can see 1 right there, 1 right there, negative 1, negative 1. So that means from the center of the circle, we're literally going exactly 1 unit for a radius. That's kind of what we're seeing here. Okay, so if we were doing this, we would just say, well, sine of theta technically equals just y then. And likewise, cosine of theta, as a result of this, is going to equal x, because it'd be y over r. R is 1. Cosine of theta is x over r, and r is 1. And this helps us when we're graphing this function. We know the a value is 1, which stands for the amplitude, which tells you how high the function goes and how low the function goes. So I can label that right here and say, hey, there's 1 and negative 1. And now when I'm looking for points, a sine function, if I were to start right here at the positive x-axis on the graph up top in the right corner and rotate around the circle, my y value starts at 0. And once it gets up to 90 degrees, it's going to be at 1. And then as it keeps rotating around here to 180 degrees, it's going to be back at 0. As it rotates to 270 degrees, the y value is going to be negative 1. And then as it rotates back to 360 degrees, it's going to be 1 again. And what I ended up doing there was I ended up plotting 5 points. And those are going to be called our 5 key points. That's kind of what we always want to look for. Okay, that's when we're graphing these functions. So now when I graph this particular function, this is where it gets a little bit confusing, because we're talking about sine and cosine here. And it says y equals sine of x. So, I mean, the y makes sense. This one's a little confusing because down here it says y equals cosine of x. Because now, when we're talking about cosine, the cosine is going to be the y values. And the x-axis on both these graphs is actually going to be represented by degrees in this case. So, for example, when we start rotating, we're starting at 0 degrees on the circle. So this is 0 degrees. And we said we rotated to 90 degrees, and that's when we got to the 1 comma 0 up here. We rotated to 180 degrees, and we got to the negative 1 comma 0. And then we rotated to 270 degrees, we got to 0 comma negative 1. And then we rotated to 360 degrees, and we got back to 1 comma 0. And now if I were to graph the sine function, it's going to look like a nice smooth curve. It's not going to be really sharp edges, smooth curve through all the points, but it's going to hit the maximum value at 1, and it's going to hit the minimum value at -1. Really important here, I'm going to use a black highlighter here. As we're going here, we see that the y value, the sine value function is positive here. And if we think about the circle, it represents the y-axis of the circle. Okay. Notice that the y values here are always greater than 0. And as soon as we cross the x-axis here, now we're going to go into negative values. And we see that on our graph. Now we start going into negative values after 180 degrees. All the y values in quadrants 3 and quadrants 4 around the circle are going to be negative values. And that's how this circle up top relates to the graph. All right, so for each function, I'm going to ask you to identify the amplitude and the period of the function. So amplitude, I highlighted in red already, and then period, I'll highlight in blue. Well, the amplitude corresponds to what we're going to call the A value. I'm going to highlight down here below. We've got the graphs, and we have A equals sine of B of x and A equals cosine B of x. So whatever number is in front of the sine or the cosine represents our amplitude. In this case, there's no number written for y equals sine of x, and that's why we say the amplitude equals 1. All right, to find the period of a function, we're going to look for the b value, and that's the number after the sine or the cosine. In this case, b equals 1. And the period of the function is how far is one full rotation. So one full trip around the circles. And this one's kind of tricky. The period for this function is going to be 360 degrees. And the way we calculate the period is we're always going to do 360 degrees divided by b. If we're using radians, which you might have in Mr. Street and Mr. Ford's class already, you might have seen radians already, then we would use 2 pi divided by b. It's the same thing, just different measurements, but today we're focusing on degrees only. 360 divided by b. In this case, our b value is 1, so this is just 360 degrees. That's how we calculate our period of the function. And now the last thing I want you to do is identify some key points. We're always going to be talking about 5 points of these functions. Those 5 points are the 5 that we graphed or we plotted before we sketched our graph. I'm going to go over those again over the highlighter. Those are 3 of those points in this case are intercepts. There's one at 0, 0. There's one at 180, 0. And there's one at 360, 0. Those would be considered intercepts of this function. The maximum value in this case is going to be 90, 1. It's just like looking at a graph. We go across the x-axis to 90, up to 1. Okay, 90, 1. And then the minimum value is 270, 1. So whenever I ask you to find the 5 key points, that's what I would be referring to, the 5 key values. Okay, for the cosine function, very similar to the sine function. Notice that there's no a value, so this is going to be another one where it says a equals 1. There's no b value next to that x, so this is another one where it's going to be b equals 1. So therefore, we're going to say 360 divided by b, which is 360 divided by 1. So the period of this function is also 360 degrees. The big difference with cosine functions, when we start with these ones, look back up at the circle now, we start again at 1, 0, but this time we're looking at the x values on the circle, and the x value happens to be 1. And then it rotates around to 0, 1, and then it rotates around again to -1, 0, so the x value becomes -1. Then the x value becomes 0 again as we rotate to 270, and finally the x value becomes 1 again. Looking at x values this time instead of the y values. So what that does for our graph, when we're thinking about it, This is where it gets a little tricky. The x values on the circle are actually going to be the y values on the graph, because the x values on this graph down here are being represented by degrees: 90 degrees, 180 degrees, 270 degrees, 360 degrees. And again, thinking about back to our Ferris wheel, we're just talking about the rotation angles. When we rotate 90 degrees, what's the x value on the circle? Well, it's going to be at 0. And when we started at 0, the rotation on the circle happened to be, the x value happened to be 1. And then at 180 degrees, we were down to -1. At 270 degrees, we were back to 0. And at 360 degrees, we were back up to 1. So the graph for the cosine function is going to look a little bit different than the sine function. We can graph it again, smooth, not really sharp edges. We don't want it to look like V's, like letter V's. It's going to be more like letter U's as we're graphing that. And we can see that this goes through those points. We want to put arrows on the end of our graphs. Don't forget to put arrows on the ends to represent this function goes on forever in both directions. This is just one period of the function before it starts repeating. Okay, that's what happens with the Ferris wheel too. You go one full rotation, and then you're back to the starting point, and you do another full rotation. That's what happens on these graphs. You do one full rotation, and then once you get to this point at 360, you go back down, and you start another rotation. The graph's going to just repeat. Okay, that's why it's a sine function or a cosine function. They're repetitive. They go over and over again. Identify our 5 key points. This time our intercepts, we notice that there are only 2, 90, 0, and 270, 0. Our maximum value, there happen to be 2 maximum values this time. There's one at 0, 0, and one at 360, 0. And our minimum value is at 180, -1. Sorry, our maximum value, I made a small mistake there. They're not going to be 0, 0. They're going to be 0, 1, and 360, 1. My mistake on that. And the minimum value is 180, -1. But again, we have 5 points. This time there's 2 intercepts, 2 maximums, and a minimum. Before there were 3 intercepts, 1 maximum, 1 minimum on the sine function. That's the idea here. As we move on, graphing key points, it says each graph below shows 5 key x values on the intervals 0 is less than or equal to x, is less than or equal to 360. It's 360 degrees over b. And that's just saying that's the period of the function. Okay, that you can use to sketch a graph of y equals a sine b of x and y equals a cosine b of x, whenever a and b are both greater than 0. These x values are where we're going to find the maximum minimum values occur and the x-intercepts. Okay, and then there's sketches of these 2 graphs. This is what your sine graph is always going to look like. On the left, your sine graph always going to be this nice start at 0, end at 0 thing. And your cosine graph is always going to be starting at the maximum, dipping down to the minimum, ending back at the maximum. Doesn't matter what the amplitude is, doesn't matter what the period of the function is. Whenever we're sketching one period, we should be able to draw these pictures. That's really the goal of today's lesson. So what I want to be able to do now, when we look at examples, for the first one, I see sine function. I see that there's going to be this weird 2 and there's going to be this -3 there. But first thing I notice, sine function, I know what that picture is going to look like. It's going to start at 0, go to the maximum, back to 0, down to the minimum, back to 0. And then I can sketch it. That's a sine function. I don't know any of the other values yet, but I know this function is going to look like that. Now, the key here is I see there's an a value of 2 in front. That's our amplitude. So this is going to be a equals 2. That means this function goes 2 units higher than the middle, and it goes 2 units lower than the middle. So generally I can say, okay, if my middle is at 0, I'm going up 2, and I'm going down 2 from that. But there's one little problem with that on this graph. I also have this -3 here, And that minus 3 is actually a shift. It's shifting the whole function down 3 units. So that minus 3 means that this is actually negative 3 at the middle. And I'm not going up to 2 and down to negative 2. That doesn't make any sense that negative 2 is below negative 3. What's really happening, I have to erase those numbers. What's really happening is I'm going up 2 units from negative 3. So I'm going up to negative 1, and I'm going down 2 units to negative 5 from that middle part. So again, this is where this d value comes in, which I'll highlight in blue over here as well. We see these generic functions, okay, a sine b of x plus c plus d, and then a cosine of b of x plus c plus d. And that d value is just what's going to be called the midline, which we've talked about already. That's the equation of the midline. And we can say d equals negative 3 here. Okay. There was no b value in this one. Well, there was. There's no number there, so that means the b value equals 1. So the period is 360 degrees. All right. So that means we're going to start at 0 degrees. The maximum is going to be at 90 degrees. And then back to 0 at 180. Over to 270 at the minimum. Back to 0 at 360. And then we can plot our 5 key points. There's one at 0, negative 3. There's one at 180, negative 3. And there's one at 360, negative 3. Now this is kind of weird because I call this intercepts, but they're not really intercepts anymore because the y values are negative 3. They're the intercepts of the midline is the best way to think about them. Those are the key points here. The intercepts of the midline. So we'll say of midline here. Not always the intercepts of the x-axis. So that can be a little tricky too. The maximum value for this one, there's only one for this period of the function. It's going to be 90, negative 1. And the minimum value is 270, negative 5. So notice that I sketched to the graph first because I knew it was a sine function. And then after that, I built the graph around it. I was able to label my maximum point, my minimum point, and all of my x values. I think that's the best way to approach these types of problems. One more example here. I see cosine, and this time I see there's a b value. It says b equals 10. There's no a value, so that's going to be, or there is an a value, it's just 1. We just don't see it. And then there's going to be a d value, so that's the midline, d equals 2. So first I can label the midline as 2. It's a cosine function, so I can actually sketch my cosine function. Hey, there's the maximum. That's going to go to 0, then down to the minimum, back to 0, back to the maximum. Technically, that's probably the first thing to do before I even label the 2. All of my cosine function, it's going to look like that, and I can fix everything else around it. Since b equals 10, my period is 360 divided by 10. 360 divided by 10 is 36. So this is where it gets a little bit trickier now. I know this function is going to end at one period at 36. Okay? It's going to hit, before it used to be 360 as we saw in the green one, and halfway was 180. So we have to think, what's half of 36? That's going to be 18. And then half of 180 was 90. Well, half of 18 is going to be 9. That's how we kind of figure out these points. And then halfway between 18 and 36 is 27. So what's really happening is we're going like 1/4, 2/4, 3/4, 4/4 all the way across. So it's like 1/4 of the way across, 2/4, 3/4, 4/4. And if you did 1/4 of 36, you would get 9. If you did 2/4 of 36 or half of 36, you'd get 18. If you did 3/4 of 36, you'd get 27. So once you find that final value of 36 at the end, you're going to want to go ahead and figure out what's 1/4, 2/4, 3/4 of it to find the other 3 points. And then this function started at 0. So we go from 0 degrees to 36 degrees is one full rotation. Because the a value is 1 and the midline is at 2, so we're going to go up 1 from 2, which is to 3, and we're going to go down 1 from 2 to 1. So that's how we're going to label the y-axis this time to represent what one period of the graph looks like. The last thing we have to do once we have all these values assigned is we're going to write down the 5 key points. In this case, it's a cosine function. It's going to have 2 intercepts. One of them is going to be at 9, 2, even though it's not a real x-intercept. It's kind of a weird way to think about it though. The other is going to be at 27, 2. Maximum values, it looks like there are going to be 2 of them on this graph. One of them is going to be at 0, 3, and the other is going to be at 36, 3. And then the last one is the minimum value. Looks like there's only one minimum value for this problem. It's going to be at 18, 1. All right, that covers everything for today. Have a great week. Make sure to check in for office hours if you have any problems with the homework assignment. Thank you.